Hello students, welcome to Maths class. In Chapter 8 Quadrilaterals, today's topic is properties of a parallelogram. Here we are going to solve some problems using the theorems which we have already learnt in the previous class. Let's recall all the theorems which we proved in a previous class on this topic before we continue. Theorem 1. The diagonal of a parallelogram divides it into two congruent triangles. Theorem 2. In a parallelogram, opposite sides are equal. Theorem 3. If each pair of opposite sides in a quadrilateral is equal, then it is a parallelogram. Theorem 4. In a parallelogram, opposite angles are equal. Theorem 5. If in a quadrilateral, each pair of opposite angles is equal, then it is a parallelogram. Theorem 6. The diagonals of a parallelogram bisect each other. Theorem 7. If the diagonals of a quadrilateral bisect each other, then it is a parallelogram. So a quadrilateral is a parallelogram if each pair of opposite sides in it is equal. A quadrilateral is a parallelogram if each pair of opposite angles is equal. Also, a quadrilateral is a parallelogram if its diagonals bisect each other. There's another criteria for a quadrilateral to be a parallelogram. That is Theorem 8. A quadrilateral is a parallelogram if one pair of opposite side is equal and parallel. So let's solve some example problems using these theorems. Example 1. Show that each angle of a rectangle is a right angle. We know that a quadrilateral in which both the pairs of opposite sides are parallel and an angle is 90 degree is a rectangle. So let's consider a rectangle with one of an angle is equals to 90 degree and show that each angle of a rectangle is a right angle. For solution, given ABCD is a rectangle such that angle A is equals to 90 degree. To show angle A, angle B, angle C and angle D is equals to 90 degree. Solution, ABCD is a rectangle. Therefore, ABCD is a parallelogram. This implies AB is parallel to CD and AD is parallel to BC. That is, opposite sides are parallel. Now, AB is parallel to BC and AD is the transversal. Therefore, angle A plus angle B is equals to 180 degree. Allied angles are supplementary. That is, 90 degree plus angle D is equals to 180 degree. Transposing 90 degree, we get angle D is equals to 180 degree minus 90 degree. So angle D is equals to 90 degree. Now we know that opposite angles of a parallelogram are equal. So angle A is equals to angle C, which is equals to 90 degree. Also angle D is equals to angle B, which is equals to 90 degree. Thus angle A is equals to angle B plus angle A is equals to angle B, which is equals to angle C, which in turn equals to angle D, which is equal to 90 degree. Therefore, each of the angles of a rectangle is a right angle. Hence, proved. Now moving on to next example. Example 2. Show that diagonals of a rhombus are perpendicular to each other. Solution. Given ABCD is a rhombus and diagonals AC and BD intersect at O. To show BD is perpendicular to AC, that is, angle AOD is equals to angle DOC, which is equals to angle COB, which in turn equals to BOA, which is equal to 90 degree. Solution, ABCD is a rhombus. Therefore, AB is equals to BC, which is equal to CD, which is equals to DA. Let's take it as equation 1, since all the sides are equal in a rhombus. Also, ABCD is a parallelogram. So diagonals bisect each other. Therefore, AO is equals to CO and DO is equals to BO. Let's take it as equation 2. Now to show that angle AOD is equals to angle DOC, which is equal to 90 degree. First, we'll show that both angles are equal by using congruence rule. So now in triangle AOD and triangle COD, AD is equals to CD from equation 1, AO is equals to CO from equation 2, and OD is common to both the triangles. So OD is equals to OD common. Therefore, triangle AOD is congruent to triangle COD by SSS congruence rule. This implies angle AOD is equals to angle COD by CP/CT. But angle AOD plus angle COD is equals to 180 degree because they make a linear pair. That is, twice angle AOD is equals to 180 degree. Angle AOD is equals to 180 degree by 2. Therefore, angle AOD is equals to 90 degree. This implies angle AOD is equals to angle COD, which is equal to 90 degree. Again, angle AOD is equals to angle BOC and angle COD is equals to angle BOA. That is, vertically opposite angles are equal. This implies angle AOD is equals to angle DOC, which is equals to angle BOC, which is equals to angle BOA, which is equals to 90 degree. Therefore, BD is perpendicular to AC. Hence, we can say that diagonals of a rhombus are perpendicular to each other. Now, let's go for the next problem. Example 3. ABC is an isosceles triangle in which AB is equals to AC. AD bisects external angle PAC and CD is parallel to AB. We need to show that angle DAC is equals to angle BAC and ABCD is a parallelogram. This is the figure given to us. Solution. ABC is an isosceles triangle in which AB is equals to AC. AD bisects the exterior angle PAC, that is, angle PAD is equals to angle DAC, and CD is parallel to AB. To show angle DAC is equals to angle BCA. Also, ABCD is a parallelogram. Solution. ABC is an isosceles triangle and AB is equals to AC. Therefore, angle ABC is equal to angle ACB. Angles opposite to equal sides are equal. Now, PAC is the exterior angle of triangle ABC. So, angle PAC is equals to angle ABC plus angle ACB. This implies PAC is equals to twice angle ACB. We'll take it as equation 1 since angle ABC is equals to angle ACB. Since AD bisects angle PAC, we have angle PAD equals angle DAC. This implies angle PAC is equals to twice angle DAC. Let's take it as equation 2. From equation 1 and 2, we have twice angle ACB is equals to twice angle DAC. Therefore, angle ACB is equals to angle DAC. So, we have showed the first part, that is, angle DAC is equals to angle BCA. Now, to show ABCD is a parallelogram, we have proved that angle ACB is equals to angle DAC, but these are alternate angles formed by transversal AC with AD and BC and are equal. Therefore, AD is parallel to BC. Also, CD is parallel to AB. is given to us. This implies ABCD is a quadrilateral in which both the pairs of opposite sides are parallel. Therefore, ABCD is a parallelogram. Now let's go for next problem. Example 4. Two parallel lines L and M are intersected by transversal P. Show that the quadrilateral formed by the bisectors of interior angles is a rectangle. This is the figure given to us. Solution given PS is parallel to QR and transversal P intersecting them at A and C respectively. Bisector of angle PAC and angle ACQ intersect at B, and bisector of angle ACR and angle SAC intersect at D. We need to show that ABCD is a rectangle. So to show that ABCD is a rectangle, we have to show that ABCD is a parallelogram in which one of the angle is 90 degree. And to show that ABCD is a parallelogram, we have to show that opposite sides are parallel. So first we'll show that opposite sides are parallel. Solution: PS is parallel to QR and AC is the transversal. Therefore, angle PAC is equals to angle ACR. Alternate angles are equal. This implies half of angle PAC is equals to half of angle ACR. So, angle BAC is equals to angle ACD. Since BA is the bisector of angle PAC and CD is the bisector of angle ACR. But these are alternate angles formed by the transversal AC with AB and CD and are equal. Therefore, AB is parallel to CD. So we got one pair of opposite sides which are parallel. Similarly, angle SAC is equals to angle ACQ. Again, alternate angles are equal. This implies half of angle SAC is equals to half of angle ACQ. Since AD is the bisector of angle SAC and BC is the bisector of angle ACQ, we can say that angle DAC is equals to angle ACB. But these are alternate angles formed by transversal AC with AD and BC and are equal. Therefore, AD is parallel to BC. Thus, ABCD is a quadrilateral in which both the pairs of opposite sides are parallel. Hence, ABCD is a parallelogram. Now, angle PAC plus angle SAC is equals to 180 degree linear pair. This implies half of angle PAC plus half of angle SAC is equals to half of angle 180 degree. Since AB and AD are the bisectors of angle PAC and SAC. So, angle BAC plus angle CAD is equals to 90 degree. Therefore, angle BAD is equals to 90 degree. So, ABCD is a parallelogram in which one of the angle is 90 degree. Thus, ABCD is a rectangle. Moving on to next example. Example 5. Show that bisectors of angles of a parallelogram form a rectangle. That is, in a parallelogram, bisectors of its angle intersect to form a quadrilateral. We need to show that it would be a rectangle. The solution: given ABCD is a parallelogram, P, Q, R and S are the point of intersection of the bisectors of angle A and angle B and angle C and angle D and angle D and angle A respectively. We need to show that PQRS is a parallelogram. Solution: ABCD is a parallelogram. This implies AB is parallel to CD and AD is parallel to BC. Now AB is parallel to CD and AD is the transversal. Therefore, angle A plus angle D is equals to 180 degree. Allied angles are supplementary. This implies half of angle A plus half of angle D is equals to half of 180 degree. That is, angle DAS plus angle ADS is equals to 90 degree. Since AS and DS are the bisectors of angle A and angle D respectively. But in triangle ADS, angle DAS plus angle ADS plus angle ASD is equals to 180 degree. Angle sum property of a triangle. Now angle DAS plus angle ADS is equals to 90 degree. This implies 90 degree plus angle ASD is equals to 180 degree. Transposing 90 degree, we get angle ASD is equals to 180 degree minus 90 degree. Therefore, angle ASD is equals to 90 degree. Again, angle ASD is equals to angle RSP, vertically opposite angles. Therefore, angle RSP is equals to 90 degree. Similarly, in triangle ABP, we can find angle APB is equals to 90 degree. So, angle SPQ becomes 90 degree. Then in triangle BCQ, we can find angle BQC is equals to 90 degree. Therefore, its vertically opposite angle PQR becomes 90 degree. Similarly, in triangle CDR, we can find angle DRC is equals to 90 degree. That is, angle SRQ is 90 degree. So similarly, we can prove that angle SRQ is equals to 90 degree, RQP is equals to 90 degree, and QPS is equals to 90 degree. This implies PQRS is a quadrilateral in which all the angles are right angles. Therefore, ABCD is a rectangle. Moving on to the last example problem. Example 6. ABCD is a parallelogram in which P and Q are the midpoints of opposite sides AB and CD. If AQ intersects DP at S and BQ intersects CP at R, show that APCQ is a parallelogram, DPBQ is a parallelogram, and PSQR is a parallelogram. The solution given: ABCD is a parallelogram. P and Q are the midpoints of side AB and CD respectively. S is the point of intersection of AQ and DP, and R is the point of intersection of BQ and CP. We need to show that APCQ is a parallelogram, DPBQ is a parallelogram, and PSQR is a parallelogram. Solution: ABCD is a parallelogram. Therefore, AB is parallel to CD and AB is equal to CD. Since opposite sides are parallel and equal in a parallelogram. Now, in quadrilateral APCQ, AP is parallel to QC since AB is parallel to CD. Again, since AB is equals to CD and P and Q are the midpoints of side AB and CD, half of AB is equals to half of CD. That is, AP is equals to QC. This implies AP is parallel to QC and AP is equals to QC. So, APCQ is a quadrilateral in which a pair of opposite sides is parallel and equal. Therefore, APCQ is a parallelogram. Similarly, in quadrilateral DQ is parallel to PB and DQ is equal to PB. Therefore, DPBQ is a parallelogram. Now, in quadrilateral PSQR, SQ is parallel to PR since AQ is parallel to PC. Opposite sides of parallelogram APCQ and PS is parallel to RQ since DP is parallel to BQ. Opposite sides of parallelogram DPBQ. So, PSQR is a quadrilateral in which both the pairs of opposite sides are parallel. Therefore, PSQR is a parallelogram. That's all for now, students. We will be solving more problems on these theorems in exercise 8.1 in our next class, students. So see you in the next class. Thank you.